Chapter 2. Exponents or powers. Many times we come across very large numbers or very small numbers. It is difficult to write their full form. Here we make use of exponents or powers so that the expression becomes smaller and easy to remember. Example: 1,010,00,000 or can be expressed as 10 raised to the power 6. 1,100 crores or can be expressed on 10 raised to the power 9. 1,000,000,000 crores or can be expressed as 10 raised to the power 12. In all such above cases, it is difficult to remember how many zeros after 1, but it is much easier to remember 10 raised to the power 6, 10 raised to the power 9, 10 raised to the power 12, etc. We have read in our earlier class that if a is a real number and n be a positive integer, then a multiply n times is equal to an raised to the power n, where a is called the base and n is called the exponent or power. We have seen that integers can be written in exponential form. Rational numbers can also be written in exponential form. Examples: a 3/4 multiply 3/4 multiply 3/4 is equal to 3/4 raised to the power 3. b -5/7 multiply -5/7 multiply -5/7 multiply -5/7 is equal to -5/7 raised to the power 4. We have read laws of exponents in our earlier class. Quickly we refresh our memories. Laws of exponents. 1. X raised to the power a multiply x raised to the power b is equal to x raised to the power a plus b. Here, x is a rational number and a and b are positive integers. Example: 1/5 raised to the power 2 multiply 1/5 raised to the power 3 is equal to 1/5 raised to the power 5. 2x raised to the power a divide x raised to the power b is equal to x raised to the power a minus b, a greater than b, is equal to 1/x raised to the power b minus a, where b greater than a. Examples: a 1/5 raised to the power 5 divided by 1/5 raised to the power 4 is equal to 1/5 raised to the power 5 minus 4 is equal to 1/5. b 1/5 raised to the power 4 divided by 1/5 raised to the power 6 is equal to 1/1/5 raised to the power 6 minus 4 is equal to 1/1/5 raised to the power 2 is equal to 5 raised to the power 2. 3. X raised to the power a raised to the power b is equal to x raised to the power a b. Example: 1/5 raised to the power 2 raised to the power 3 is equal to 1 upon 5 raised to the power 2 multiply 3 is equal to 1 upon 5 raised to the power 6. 4. If x and y are two rational numbers and a is any positive integer, then xy raised to the power is equal to x raised to the power a multiply y raised to the power a xy raised to the power a is equal to x raised to the power a multiply y raised to the a. Example: 3 upon 4 multiply 5 upon 6 raised to the power 3 is equal to 3 upon 4 multiply raised to the power 3 multiply 5 upon 6 raised to the power 3. 5. The rational number 1 raised to any exponent remains as 1. Examples: a. 1 raised to the power 10 is equal to 1. b. 1 raised to the power 5 is equal to 1. 6. Any rational number raised to the exponent 1 is the number itself. Examples: a. 15 upon 17 raised to the power 1 is equal to 15 upon 17. b. Minus 5 upon 8 raised to the power 1 is equal to minus 5 upon 8. 7. When exponent is not mentioned, this means exponent is 1. Negative exponent. If x upon y be a rational number other than 0, then x upon y raised to the power minus 1 is the reciprocal of x upon y, that is, y upon x. If x is any non-zero rational number and a is any positive integer, then the reciprocal of x raised to the power a is equal to 1 upon x raised to the power a is equal to x raised to the power minus a. Examples: a. 5 upon 6 minus 1 is equal to 1 over 5 upon 6 is equal to 6 upon 5. b. 4 raised to the power minus 5 is equal to 1 upon 4 raised to the power 5 is equal to 1 upon 4 multiply 4 multiply 4 multiply 4 multiply 4 is equal to 1 upon 1024. c. 2 upon 3 raised to the power minus 4 is equal to 1 over 2 upon 3 raised to the power 4 is equal to 1 over 2 upon 3 multiply 2 upon 3 multiply 2 upon 3 multiply 2 upon 3. 3 upon 2 multiply 3 upon 2 multiply 3 upon 2 multiply 3 upon 2 multiply is equal to 81 upon 16. If x upon y be any rational number, then x upon y raised to the power 0 is equal to 1. Examples: a. 5 raised to the power 0 is equal to 1. b. 3 upon 4 raised to the power 0 is equal to 1. Laws of exponents with integral power. We have studied laws of exponents when the exponents have positive powers. Let us find out if these laws are true for negative integral powers also. It will be easier if we come to conclusions through some examples. Example 1. Verify. 5 raised to the power 6 multiply 5 raised to the power minus 2 is equal to 5 raised to the power 4. Solution. LHS is equal to 5 raised to the power 6 multiply 5 raised to the power minus 2 is equal to 5 raised to the power 6 multiply 1 upon 5 raised to the power 2 is equal to 5 raised to the power 6 minus 2 is equal to 5 raised to the power 4 is equal to RHS. Uses of exponents to express large numbers and small numbers in standard form. A number is said to be scientific notation or standard form if it can be expressed in the form A. Multiply 10 raised to the power n, where A is any integer lying between 1 and 10 and n is an integer. To write a number in standard form, we may use following steps. Step 1. Obtain the number and see whether the number is between 1 and 10 or it is less than 1. Step 2. If the number is between 1 and 10, then write it as the product of the number itself and 10 raised to the power n. Step 3. If the number is less than 1, then move the decimal point to the right so that there is just one digit on the left side of the decimal point. Write the given number as the product of the number so obtained and 10 raised to the power n, where n is the number of places the decimal point has been moved to the right. The number so obtained is the standard form of the given number. Step 4. If the number is greater than 1, then move the decimal point to one left so that there is just one digit on the left side of the decimal point. Write the given number as the product of the number so obtained and 10 raised to the power n, where n is the number of places the decimal point has been moved to the left. The number so obtained is the standard form of the given number. Examples. A. 34.0 is equal to 3.4 multiply 10 is equal to 3.4 times 10 raised to the power 1. B. 3.4 is equal to 3.4 multiply 1 is equal to 3.4 multiply 10 raised to the power 0. C. 0.34 is equal to 3.4 multiply 1 upon 10 is equal to 3.4 multiply 10 raised to the power minus 1. D. 0.034 is equal to 3.4 multiply 1 upon 100 is equal to 3.4 multiply 1 upon 10 raised to the power 2 is equal to 3.4 multiply 10 raised to the power minus 2. E. 0.0034 is equal to 3.4 multiply 1 upon 1000 is equal to 3.4 multiply 1 upon 10 raised to the power 3 is equal to 3.4 multiply 10 raised to the power minus 3. F 0.00034 is equal to 3.4 multiply 1 upon 10,000 is equal to 3.4 multiply 1 upon 10 raised to the power 4 is equal to 3.4 multiply 10 raised to the power minus 4. Example 1. Write the following numbers in standard form. A 0.00000832. B 0.000000000409. C 30 crores 40 lakhs. Solution. A 0.00000832 is equal to minus 8.32. Multiply 10 raised to the power minus 6. The decimal point is moved 6 places to the right. B 0.000000000409 is equal to 4.09 multiply 10 minus 12. The decimal point is moved 12 places to the right. C 30 crores 40 lakhs is equal to 3.04 multiply 10 raised to the power 8. The decimal point is moved 8 places to the left.